Hi everybody, today we're learning about mass spectrometry. It's very similar to a cathode ray tube if you're familiar with that. You take a sample that you want to measure what's in it, and it's kind of neat because you can measure not only the elements but the isotopes and their masses. So mass spectrometry measures stuff by mass, of course. You ionize the sample. There's lots of ways to do it. Beam of electrons, laser when you have the sample coated already on a matrix that can be blasted apart. But anyway, you ionize it, so you blast the sample into pieces that are positively charged by ionizing, by taking off electrons, and you put that in an electric field, and so the positive particles will be drawn through the electric field. And there's variations on this, but the simplest way is that the smaller particles move faster through the electric field and the heavier particles move slower. When the particles hit the detector, their mass is calculated based on the position they hit at or based on their time of flight, the time it takes to get to the detector, and you get a signal. So the light particles would give a low mass to charge signal, and then when the heavier particles got there, they would give a heavier mass to charge signal. And then the y-axis is relative intensity, so if there's more particles you'll get a bigger peak than if there's less particles. The first spectrum on your handout is hydrogen here. So the red line, I know it's not red on your handout, that's basically all the hydrogen. So you can see that hydrogen comes as H2, so its mass is 2. So most of the signal is up here, and then you also get a very small peak in these graphs at half the molar mass from particles that get a +2 charge, because it's it's mass over charge. So a +2 charge will give you half the mass as you expect. And then the rest of it is H2. So hydrogen has really a lot more of it that is hydrogen 1 than deuterium or tritium. But if there's isotopes that are more, it's more abundant of the different isotopes, you see other peaks, like in our next example. So let's look at this one. We see a big peak at 32, very small peak at 16. So what would that be? Well, again, this is 32 divided by +2 is where we get that. And then this one would be O2. So you look at the mass of the major peaks and you figure out what they're made out of based on the masses. Here's a more interesting one. So we see the biggest peak is at 70. So go ahead and look on your periodic table, pause the video, and figure out what element this would be, and then talk with your partner about what causes the other peaks. So we've got a 35 and a 37. That one is chlorine 35, and this one is chlorine 37. Different and common isotopes of chlorine. You can see that the average mass of chlorine is 35.45, so that means that there's a significant amount of chlorine that is heavier, that one. Notice there's not chlorine 36, because that's not an isotope of chlorine. Okay, so the 70 would be Cl2, that's made out of a chlorine 35 and a chlorine 35. The 72 would be a 35 with a 37, and then the 74 would be a 37 and 37. Go ahead and pause again and talk with your partner about why the relative sizes of these peaks make sense. Okay, moving on. So this one is bromine 79. So if you look on the periodic table, this one's kind of tricky. And then next to it is bromine 81. So the average mass of bromine doesn't really look like 79 or 81 because it's a average. So then talk with your partner about what causes each of these bigger peaks, please. Go ahead and pause the video. Okay, so we've got two 79s making 158. We've got a 79 and an 81 making 160. And we've got a 81, two 81s making a 162. If you're into stats, you can talk with your partner about the relative sizes of these peaks. And moving on. Oh, before we move on, notice there's those little half peaks again from the +2 charges. Okay, last one we're doing together. This one's a little bit trickier because it's not an element, it's a compound. So compounds can get blasted apart into more variations than elements because they're made up of more than one element. Go ahead and pause the video and try to predict what compound is this and what causes each of the peaks. Okay, so you look at the heaviest one to find the whole molecule. So the whole molecule has a mass of 44. By the way, I think in the last slide I might have said the mass wrong for that heaviest peak, but I labeled it. And then we've got to figure out what causes 12 and 16 and 28, and then this is kind of confusing right here until we realize, oh, this is just half of the molecule peak. So that's carbon 12, that's oxygen 16, that's a carbon 12 and oxygen 16 together, and the whole thing would be CO2. We've also got a couple of little heavier peaks, so we can explain those by saying that it's CO2 with a molar mass of 45 or a molar mass of 46, so maybe there's oxygen 17 or maybe there's a carbon 13, something like that. That's a little bit weird because we don't see any here, but maybe there's just sensitivity problems or I don't know what. Okay, talk with your partner, see if you have any questions, and the extra credit today, and it's not the type of problems you'll be tested on. So this is as hard as they get, is something like this for your test.